the equation of a straight line L is given by this. And of course, it's not particularly in the form y is equal to mx plus c, right? Notice I didn't read the rest of the question yet. I just noticed here that this is not in the form that I am used to. So I gonna put it in the form. So that gonna be negative 4y is equal to, I throw across the 3x, it'll be minus 3x plus 5. And then I throw across this negative 4. Everything will be divided by negative 4. So it'll be negative 3x over negative 4 plus 5 over negative 4. And so that will give us 3 over 4x minus 5 over 4. And this is pretty much the line that we're talking about, right? Write the equation of the line L in, well, all right, well, look. We did. You see how it does work? It does work out, you know. As soon as you get a piece of information, work on it. Don't even read the rest of the question, because most likely by the time you finish work the information that you have, you're probably done answer the question already, right? Hence, determine the gradient of the line L. So the gradient of the line L, and they say hence, is obviously m. So part 2, right? This is m. So m is gonna be 3 on 4. The point P with coordinates R and 2 lie on the line L. Determine the value of R. Well, I mean, that's X and Y, and all they're asking for here is what is X when Y is 2. Yeah, so at R2 implies you have Y is 2, so that is 2 is equal to 3 over 4R, because R is X, minus 5 over 4. Well, I guess I'll throw this across on this side. So now I can have 3 over 4r is equal to, it'll be plus 5 over 4, and I'll use, instead of 2, I'm going to use 8 over 4. Just to, you know, and I could probably multiply this whole thing by 4, honestly. 8 and 5 is 13 on 4. Yeah, I wonder if I multiply, but then I'll get, yeah, let me multiply the whole thing by 4 and see what'll happen. The whole thing. So that means that we will now have 3r plus 8, no, 3r is equal to 8 plus 5. 8, 9, 10, 11, 12, 13. So 3r is equal to 13r. Yeah, I think you would have probably get the same thing. 13 on 3, which is 3 3s are 9, 4 3s are 12, 4, 12 and 1/3, 4 and a third. Anybody, did you get 4 and a third, Ethan?
So I get 2 points, no, 275.
275?
2.75, sorry.
All right, 2.75. All right, well, let me see if I didn't multiply. I don't know if this multiplying it by 4 would have affected it, but I don't think so. But I don't think so, because it's equivalent. Yeah, I think it's 4 and a third. By the way, we don't like decimals, especially in admaths. At the admaths level, only use decimals if you really have to. But we don't like decimals. Our favorite thing is rational, a rational improper fraction. Yeah, that's the easiest thing to work with. So if I didn't, this would have be, yeah, oh yeah, it would have worked out to be the same thing. Yeah, it would have worked out to be the same thing. Yeah, 4 and 3. If I didn't remove the 4, it would have just be 13 on 4, and then you would have had to remove the 4 anyway, and you would have get 13 on 3, which is that, yeah. So yeah, I don't know. Where did you see where you made your mistake though? That's the important thing.
Yes, sir.
Where was it, if you don't mind me asking?
Kinda everything.
Kinda everything. Right? Did you understand what I did here? That this is actually just the x and this is actually just the y?
Yes, sir.
All right. Is it that you were thinking too much?
No, sir, I went on GeoGebra and I put in the formula and I just was looking for the intersect.
Right, but the thing is, though, I know that you love the technology, bro, but these are past paper questions. You ain't gonna have GeoGebra in the exam room.
No, sir, I couldn't get it. That was the thing. I just couldn't get it.
Okay, you could. Yeah, but watch how easy it was, though. Right, it didn't require anything more than what we did. You know, you understand it, right?
Yes, sir.
All right, just. So I think it really is a matter of overthinking. Yeah. You're thinking too much, bro. You're making it too complicated. By the way, this question is actually a O-level CSEC maths question. Right? This is an actual O-level past paper question from normal CSEC math. Find the equation of the straight line passing through the point. So this now here is number 4. I am required to find the equation of the line passing through 6,0. It's passing through 6,0 and is perpendicular to L. All right. So remember the line L, and I'll do this in a different color just to make it a little easier to understand. The line L is y is equal to 3 over 4x minus 5 over 4. And the reason why you could not get this one, Ethan, is because you just forgot that one tiny little rule that I told you to remember. Yeah, because this little rule is the little rule that they just like to test you on every time. And that is that if two lines are perpendicular, so the gradient of this line is perpendicular to the gradient of this line, then when you multiply both of them, you will get -1 every time. So they say here that this line is perpendicular to line L. So, you know, line L, let me call this here M1, right? And so the perpendicular to M1 would imply M2, right? And so therefore, M1 times M2 should give you -1 if they are perpendicular, right? M1 is 3 over 4 multiplied by what will give me -1? Well, it'll have to be -4 over 3, right? Therefore, right, this perpendicular line implies y is equal to mx plus c. Y is equal to -4 over 3x plus c. Now I had to find c. How am I going to find c? Well, that is why they gave you this point. If you was asking, well, why did they give us this point? Well, this is why. They gave us that point to find c. So therefore, at the point 60, remember this is our x value, this is our y value. So we have y is equal to -4 over 3x plus c. Y is 0 and x is 6. So that's -4 over 3 times 6 plus c. Of course, 3 will cancel. 3 2s are 6, 4 2s are 8. C is equal to 8. Because 4 2s are 8, that's -8. And when you throw it across, you'll get +8. Right? So therefore, y is equal to -4 over 3x plus 8. Understand, Ethan?
Yes, sir.
Shanisha, do you understand?
Yes, sir.
Kitara, do you understand?
Yes, I do.
All right. Now this is actually your O-level question. This is what your O-level maths question will look like. when you're writing your normal maths exam. Let me just hit done it for this. Now it have a part B, draw the lines. All you want to do that, or all you feel like you can do that. Right? This have nothing to do with the other question though. But I think all you can handle that, right? Or do you guys want me to do it? You all want me to do part B there to draw them 2 lines on a graph? Or do you all think you can handle that?
I said you could do it.
You want me to do it? No problem. Just let me hear some donuts for this.
Done
I'm just gonna get some more water coming back, right?
it. Done
One more done. So let's draw 2 lines. And of course, it have a difference between draw and sketch. Nice. So we have to draw. Draw doesn't mean sketch. Draw means draw. These lines, and I'm gonna put this line here. I'm gonna put this line here in the form y is equal to mx plus c. And immediately you are supposed to be able to look at this and tell that, okay, this line is going to have a negative gradient and it's gonna be cutting at 10. Alright. I don't know where it cut in here. Alright. I don't know how steep it is, but it does have a negative gradient. Right? And so it's gonna be cutting at 10. So I don't know that this line gonna look something like this. You're supposed to be able to look at your lines and immediately tell. And of course, this here is the quintessential line y is equal to x, right? And that line is the line that divides the Cartesian plane in 2. That is this line here, right? That is where, you notice that C is 0, yeah? So that is why this is cutting at 0, yeah? So, so you're supposed to be able to just look at them and be able to do a sketch to know what you expect to get, right? Sketching it and drawing it is 2 different things. So I have the first line, y is equal to negative x plus 10, right? And what I need are 2 points, right? 2 points to draw any line, yeah? So I have my x value, I have my y value here. Let me just choose the easiest when x is 0. Right? When x is 0, notice I didn't, this table doesn't have negative x there. This table has x, so that is 0. Thankfully, the negative doesn't matter. And so y will be 10 when x is 0. Right? So I have my first point, 0, 10. That's it right there. Right? And then my second point, you could literally choose anything. How about we choose when y is 0? Right? If y is 0, I'll throw the x across here to give me x will be 10, positive 10. That means I have this point over here. Once you get 2 points, and you can literally choose anything. Be careful what you choose though. Obviously, don't choose x to be 247 because you don't have 247 on your graph. Yeah, so you need to choose numbers that you know you'll get on your graph, right? And then join them. And you notice I do have the arrows on either side showing it goes to infinity in both directions. And this here is the line y is equal to negative x plus 10. And then the second line is the line y is equal to x. And of course, if you want 2 points here, you could pick and choose because x and y will always be equal. So because y is equal to x. So if x is 0, y is 0. If x is 10, y will be 10. So you have 0, 0 here. And you have 10, 10 here. And this other line this is your line y is equal to x. Yeah. And so this is how you draw two lines. Now please note where those lines intersect. And you can see they intersect at the point 5, 5. This is actually the graphical method for solving simultaneous equations. And this is an important point. Remember when we did quadratics, we had a quadratic and we had a line, and we had to solve them simultaneously to find where the points of intersection are, right? This is point of intersection here could also be done using simultaneous equations. That is, if you have y is equal to negative x plus 10 being equation 1, and then y is equal to x being equation 2, and you solve those simultaneously, this is what you will get. This is the equation of a circle, and we're talking about the standard form here. Now imagine you have a circle, and this is the center of the circle. The center of the circle is HK. Some textbooks use AB, and that is fine as well. I will use AB later down the line, but right now I use an HK. Doesn't matter though. Just note that they are positive, right? And of course, this is the point P, which is on the circumference of the circle. This is the point XY. And of course, if we draw the right angle triangle, this side will be the side y minus k, and this side here will be the side x minus h. X, which is 5, minus h, which is 2. Yeah. And so by Pythagoras' theorem, the radius r will be a squared plus b squared, which is x minus h squared plus y minus k squared, and that is r squared. This is the standard form for the equation of a circle. This is when the center is 0, 0. When the center is 0, 0, obviously h is 0, obviously k is 0, and this will be the standard form for the equation of a circle with the center as the origin. The equation of a circle is this. Notice this is the equation of a circle. So you can have a plus in there if you want. You have to find the center, and you have to find the radius of the circle. Where's the center? Where's the radius? Well, recall the equation of a circle, the standard form. This is the standard form. X minus h squared plus y minus k squared is equal to r squared. Note, this is the equation you're dealing with. And so you want to put it in the standard form, x minus h squared plus y minus k. So you see k is actually minus 1 in order for you to get plus 1 here. In the standard form, k would have to be minus 1. So be careful. The overthinking begins. And that is equal to 17. So therefore, h is 4. K is minus 1, and hence the center is 4 minus 1. And if r squared is 17, then the radius is the square root of 17. So be careful when you're finding the center, right? When you're comparing it to the standard form is minus h minus k, and this is because the center is hk. So you want to find, the h and the k. So you just have to put it in that standard form where you have minus h minus k for you to get h and k. So just be careful. Now, check this out. Find the equation of a circle with part A. The center, and now we're finding the equation. Over here we were given the equation and we had to find the center and the radius. But over here, they're giving us the center and the radius, and we had to find the equation. So we have a center of -1, 2, and a radius of 8 units. So recall the standard form being x minus h squared plus y minus k squared is equal to r squared. That is the standard form, right? Look, I have the h and the k here. H is -1, so use the buckets, right? X minus -1 squared plus y minus k, which is 2 squared, is equal to r squared, right? Now I'll end up with x plus 1 squared plus y minus 2 squared is equal to r squared. I actually have to expand this out. And in expanding this out, I will have x squared plus 2x plus 1. Then I have this plus sign here. And expanding this out will give me y squared minus 4y plus 4. And that is equal to 64 on this side. 8 8s are 64. Now I group in ascending order. Right? Ascending order of the powers. So the powers, you always want the largest, or descending order actually, the largest of the powers first. So I have x squared plus y squared. Right, those are the powers of 2, and then the powers of 1, 2x minus 4y, right, plus 5, right, because 4 and 1 is 5. Throw across this 64, and I'll get x squared plus y squared plus 2x minus 4y minus 59 is equal to 0. This is the general form for the equation of a circle. If we look at part B, the center is 0, 0, and the radius is 5 units. So similarly, I could jump straight to x squared plus y squared is equal to r squared, which is 5 squared. Therefore, the equation implies x squared plus y squared equals 25. Now, this is something fun to plug into GeoGebra. Because you notice this form here this form here doesn't have any 2x minus 4y, right? So imagine you exclude this 2x minus 4y. You have here the equation of a circle about the origin. So the equation of a circle about the origin is just this. They have no x and y values. And when you plug it into GeoGebra, you realize that, hey, well, these guys here actually move in the circle from the origin. And they go move it 2 spaces on the x and minus 4 spaces on the y. So it's fun to play with it in GeoGebra and see what all of the different aspects of it does. What will happen if you change the x values and the y values, you know? Waiting on my donuts. Or questions.
Done it.
So you see, Ethan, how you didn't remember the perpendicular that when you multiply perpendicular radii, you just get -1. You didn't remember that, then?
Yeah.
Right. Right. That is one of those little things that, and as I say, keep that one in mind. let me tell you something, once you see the word perpendicular, that is what they're asking you for. It have nothing else that they'll ask you for that requires the word perpendicular, right? It have little things in this one as well. Anybody still writing? So, to find the general form for an equation of a circle, we're gonna use at center negative a minus b, negative a negative b, sorry, and radius r. Why are we using negatives? We're using negatives simply because we want our final equation to just have like additions in it. We generally don't like it. Have things in maths that we don't like. We don't like decimals. We prefer fractions. We don't like having surds in our denominator. You know, we don't like that. We don't particularly like having minus signs in our general formulas unless you have to. Unless you have to have a minus sign, we don't like it. We don't like division either. You know, we prefer to multiply by a fraction than to divide. Yeah. Have certain things mathematicians dislike and don't like. So, you know, when you use these negatives here, your general formula does end up being nice and clean. But please remember, Ethan, this is one of those little things you had to remember. That for the general formula of a circle, we are using this as the center. And you'll see why that's important just now. Because the standard form would imply x minus negative a, and then y minus negative b is equal to r squared. And of course, now we will get nice clean addition signs in there for us to expand. So x plus a squared expands to this. Y plus b squared expands to this. Y squared plus 2by plus b squared. Right? Note these little things. You see this 2ax? Note that. Right? Note that. Note 2by. Note that, because if you look at this equation here, right? Notice how this here is 2x. I know that 2ax is 2x. And so immediately I can see that a is 1. Yeah. And, you know, I could look at this negative 4y. Negative 4y is really 2by. So I can immediately see here that b is going to be negative 2. Right? But of course the center is not 1, negative 2. That is because the center is negative a, negative b, as I was saying. So therefore the center will be 1. Negative 1, 2. Yeah? So the reason why I say look out for this is because this here, you could watch the equation and you could tell what the center is just by looking at that and remembering this. You could just watch the equation and you know what the center is just by looking at the x value and the y value. And of course you group them together, so x squared plus y squared plus 2ax plus 2by plus all of this. You had the a squared, the b squared, and minus r squared when you bring it across. We are combining a squared, b squared, and r squared to give us c. So in this case, c is not where it has cut the y-axis. No, that's for a line. In this case, the constant c is a combination of all of the constants, including the center of the circle, that AB, minus the r. This is c. And this here is a formula that they love to bring. Right? Simply because you could use this to find r as well. Because remember, just by looking at an equation, you know what c is. you know what A and B are just by looking at the equation. You could use these values and find R, because in this case, R is going to be what? A squared plus B squared minus C, the square root of all of that. And we'll see examples of this stuff just now. Let me hear my done it's. This here is the general form of a circle. X squared plus y squared plus 2ax plus 2by plus c, where c is a squared plus b squared minus r squared. So for the standard form, the center is a positive AB. But that is why I had used HK, so you wouldn't mix them up, right? But when you really think about it, whether you use HK or AB, for the standard form, the center is a positive AB. But for the general form, you're thinking of the center as a negative AB. So check this out. And I mean, let the overthinking begin. And you can see this is the length of it here, but I'll zoom in and start a little bit on top, right? Find the center and the radius of this circle here. Now, before I go into it, I could see here, I could just watch this here and say, you know what? That is 2ax. So A is gonna be 2. And this here, this negative 6y, that stands for 2by. So B is gonna be negative 3. And seeing that the center is negative A, negative B, the center will be negative 2 plus 3. You see, I find that just by looking at it. I could just do that just by looking at it because I'm so awesome. I'm so great. Right? Of course, it have all of this here that we had to consider. But you could just look at it and work it out that easy. And remember what I was saying about, 5, right? Because we work out that, C is 5 in this case. If C is 5, that means that what? C is 5. C 5 is A squared plus B squared minus R squared. And I know, look, A is 2, so 5 is 2 squared plus minus 3 squared minus R squared. I could find R here, right? So R is going to be what? If I throw across these guys here, it'll be, no, I'll throw it across the R and I'll throw across that. So it'll be 2 squared plus negative 3 squared minus 5, and the square root of all of that. R is going to be the square root of 2 2s are 4 plus 3 3s are 9 minus 5. 9 minus 5 is 4, so R is the square root of 8. And we can leave it like that. You try it this time. And they just tell you to find the radius of the circle, eh? So, you don't have to put it in no standard form and thing. Just try part A. What's the equivalent fraction over 4 for 4? 16 over 4. 10, 9 and 1 is 10, and 10 is 20. That's 26 over 4. So you see here, Ethan, I will not reduce this to a decimal. I will leave it so, because that is the preferred form. We could work with that. A decimal you can't work with because that is an irrational number. So we have here x squared plus y squared minus x minus 3y minus 4 is equal to 0. And it is of the form x squared plus y squared plus 2ax plus 2by plus c is equal to 0, where negative x is 2ax, so therefore 2a is negative 1, and a is negative a half. Negative 3y is 2by, so 2b is negative 3, and b is negative 3 on 2. So therefore, with a center of negative a and negative b, we'll have c, the center, being a half and 3 on 2, right? Notice that's for the center. When I'm working out this radius, I'm using this AB from here. Yeah, because this here is negative A, negative B. So R squared is equal to A squared plus B squared plus, well, in this case, it would be minus C, but minus C being minus 4. I throw the minus 4 across, and it end up being plus 4. And so R squared is going to be this, which works out to be 26 on 4, which works out to be root 26 on 2. Now let's do A part 2. And A part 2, and I just, gonna hottle your head a little bit, put in standard form. Let's actually try to take this and put it in standard form. Right, so I'll have x squared plus y squared minus x minus 3y minus 4 is equal to 0. This would imply I'll group my x's, x squared minus x plus y squared minus 3y minus 4 is equal to 0. I'll do what they call completing the square. I'll notice that, and I'll do the same thing here. I'll notice that 2a is negative 1. Yeah, the a is negative a half, and I'll notice that 2b is negative 3, so b is negative 3 on 2. So therefore, I'll have x squared minus x plus a half squared. Alright, it'll be plus minus a half squared, but I'll just end up being a half anyway. You know what? Let me put the minus just not to confuse all you. Plus y squared minus 3y plus the negative 3 on 2 squared minus 4 is equal to 0. Sorry for doing all of this. I hope I could work it out. I hope so. Right? This here will end up being x minus a half squared. Because if I take x, and I'll just check it over, x minus a half into x minus a half. I'm just checking it over here. X times x is x squared. I'll have minus a half x. I'll have minus a half x. And then I have minus a half squared. So yes, it does work out. Plus, this will work out to y squared. No, not y squared. Y minus 3 on 2 squared, and then I will have minus 4. Let's see. What did they do next? Did they replace minus 4 plus 5, and they replace plus 5c with this? Notice that c is this, right? So they replace c with all of that. So I'm gonna note c is a squared plus b squared minus r squared. Therefore, I'll have x minus a half squared plus y minus 3 on 2 squared. And then I'll have plus the minus a half squared plus the minus 3 on 2 squared. Oh no, what they did, they just no, hold on. Alright, so they make r the subject, so they was c r, right? Yes, okay. So if r is the subject, then r squared is going to be they use c minus a squared minus b squared, which is so dumb. Because c, you can see here, c is minus 4. C, which is minus 4, minus a squared minus a half squared minus b squared minus 3 on 2 squared, and that is 0. So x minus a half squared, and you could see here in this standard form that the center gonna be a half and 3 on 2 one time. Y minus 3 on 2 squared, And this will be minus 4 minus 1 on 4 minus 9 on 4. And you can see we get back the same thing. So x minus a half squared plus y minus 3 on 2 squared. What did this work out to be when we added all of this? Minus r squared. R squared was 26 on 4. Yeah, so this will be minus 26 on 4. And this is r squared. Yeah, this is r squared. So therefore the standard form is x minus a half squared plus y minus 3 on 2 squared, which is equal to 26 on 4, where c is a half and 3 on 2, and r squared is 26 on 4, implying that r is the square root of 26 on 2. I actually did not intend on doing this. I was gonna move on, but I'll say, you know what? Let me go through it just so that you guys could give it a little exercise. And of course, with part B, you'll do the same thing. Put it in the standard form for me, because it is a good exercise to do so, right? So whilst the textbook wasn't wrong, you should be able to put it in standard form. But when it comes to finding the center and finding the radius, you don't have to go through all this. And of course, B part 2 as well. You'll change this to standard form as well. All right. The tangent and the normal. You notice this is a circle. The tangent touches the circle at one point, and that is the point P, which is xy. Notice we have a circle with center negative A, negative B. And so we have the radius, the tangent, and this is circle theory. The tangent will always meet a radius at 90 degrees. This is one of those little things, Ethan, that you should remember to make life easy for you, right? Because remember the perpendicular lines, right? Remember the tangent is a line with gradient m1. The radius itself is a line. Oh, well, I have the radius here having the gradient m1. The radius is a line with gradient m1. The radius is also called the normal. The normal to the tangent. Normal means perpendicular to in maths, if you're talking about geometry, right? So the radius, which is the normal, is perpendicular to the tangent. And if the radius is aligned with gradient m1 and the tangent is aligned with gradient m2, well then the normal and the tangent, their gradients will multiply to give you -1. You see it coming back again. And of course, I have the point P and I have the center C. So I could use y2 minus y1 to find the gradient of the normal. And therefore, I could find the equation of the normal. And if I have the gradient of the normal, then I could find the gradient of the tangent, and I could find the equation of the tangent. And that is what this is all about. Let me hear my Donics. Kitara, you done it?
Yeah.
Okay. Wait, anybody still writing? Kitara, I'm waiting for you to done it.
No, finish.
Oh, okay. All right. No problem. So we have a question here. And this brings us to very much the kind of question that Amara had asked us about earlier. The equation of the circle is this. And the point P, 2, 7 is a point on the circle. We don't know what the center is. Yeah. We have to find the equation of the tangent at the point P and the normal at the point P. So I'll start with my equation of the circle. And I'll say from this equation, look my 2ax here and look my 2by here. So immediately I could see that a is 5 and b is negative 6. And then for the general form, the center is minus a minus b. So therefore the center will be minus 5 and positive 6. I have the point P, which is 2, 7. So now I could draw a sketch. So I could see the sketch there. The center is negative 5, positive 6. The point P is the point 2, 7. And this is the circle, and this is the tangent at the point P. And from my sketch, I could immediately tell that my tangent is going to have a negative gradient, and that the normal, which is the radius, is going to have a positive gradient, and that they are both perpendicular to each other, right? Seeing that I have these 2 points now, I could now find the gradient of the radius, which is the normal. So the gradient of the normal, which I am calling Mn, M subscript n, is y2 minus y1 over x2 minus x1, and I'm using these 2 points. So I have 7 minus 6 all over 2 minus negative 5, and I get 1 over 7. That is the gradient of the normal. I could immediately find the gradient of the tangent, right, mt, by using the m1 times m2 equal negative 1. If I have mn, times mt equals negative 1. If mn is 1 over 7, mt will have to be negative 7 in order to get minus 1. So therefore the gradient of the tangent is negative 7. Just like what my sketch said. My sketch was expecting the tangent mt to be negative, and it was expecting the normal gradient to be positive. Therefore, the equation of the normal at the point 2, 7, right? Remember, is y is equal to mx plus c. I have m, I just don't have c. In order to find c, I'll just use the point 2, 7. Or because we're talking about the normal, you could also use the center of the circle as well. Because this is your x value and this is your y value. So I have a x, I have a y, I have a m, I could find c. So that is y is 7 is equal to m, which is 1 over 7, times x, which is 2, plus c. So c is going to end up being 47 on 7. 7 minus 2 on 7 is 49 on 7. Minus 2 on 7 is 47 on 7. And you can see, Ethan, I left it as an improper fraction because improper fractions are easier to work with than mixed numbers or decimals. So the equation of the normal is y is equal to mx plus c. And of course, I could just multiply it by 7 to get rid of all of them ugly 7s. To get 7y is equal to x plus 47. That is the equation of the normal, which is the radius. So this is the equation of this particular radius. Now remember, the radius does go all the way around there. So this equation is only the equation of the radius that joins C with P. All of the other radii will have different equations. And therefore, the equation of the tangent, well, I have -7 being the gradient of the tangent. So y is equal to mx plus c. And I could find c by using the same point P. I use the same point P here to find c. This is the x value and the y value. So y is 7 is equal to -7 times 2 plus c. So c is going to be 7 plus 14. I throw across this, right, which is 21. So the equation of tangent is -7x plus 21. Shanisha, how you feel about this one?
It's okay.
It's okay. Any questions about any parts of it?
Not really.
All right. Do you understand how I used the general equation to find the center of the circle?
Yeah.
And how I could have used the center of the circle and P to draw a sketch?
Yeah.
Do you understand how much information that sketch does give you?
Yeah.
Yes, it's pretty cool, right? And so do you understand that I could use that C and that P to find the equation of the normal and hence get the equation of the tangent, yeah?
Yeah.
All right. And then by using y is equal to mx plus c, and I'll use the point P, I could find both the equation of the normal and the equation of the tangent. You understand? I think that we will spend one more class on coordinate geometry in terms of just doing coordinate geometry questions, right? So Wednesday we'll spend doing some coordinate geometry questions just to get used to the questions. Yes, I could do a video with it, but I think it's important because of the amount of algebra involved that we do spend a class on it, right? So apart from these questions, there are past paper questions. I will give you a couple of questions like this to do. We have one more thing to do today. We might be able to finish by 12, but I am waiting on my Dunnits. So just take a screenshot of it and you'll do these for homework. And yes, we will spend one more class doing coordinate geometry questions. Last thing. We have the intersecting points. In other words, simultaneous equations. Yay! Right? A tangent meets the circle at one point P. Right? The point P being x1, y1. A secant will meet the circle at 2 points. So it's actually cutting the circle. Right? And this is the point P1 and P2. So you can see here that when a line is touching a circle or intersecting a circle, it could intersect at 1 point or it could intersect at 2 points. So when you're solving simultaneous equations, sometimes you'll get one answer. And if you get one answer, well, then you know it's a tangent. Sometimes you will get two answers. And when you get two answers, you'll know it's a secant. The line x plus y equals 9 intersects the circle x squared plus y squared minus 6x minus 4y plus 5 is equal to 0 at a point A. Find the coordinates of the point A. Well, look, I wrote down my two equations here. X plus y is equal to 9, and this one, I'm going to say that again. And of course, from equation 1, I am getting y is equal to 9 minus x, and I'm going to sub that in equation 2. So I have x squared plus y squared, y being 9 minus x. So x squared plus 9 minus x squared, minus 6x minus 4y, which is 9 minus x, plus 5 is equal to 0. Of course, I do have to expand this out. So when I expand this out, I'm going to get x squared plus, this is going to be 81 minus 18x plus x squared. Right? And you can square the two terms. So to square this 81, square this, which is 2x x squared, sorry. Then multiply the 2, which will give you minus 9x, and times 2 will give you the middle term. That's a faster way to do it. We can see here minus 6x minus 4, 9 4s are 36, plus negative 4 times negative x is plus x, plus 5 is equal to 0. And of course, we adding up all of the x's. X squared plus x squared is 2x squared. I'll have minus 20x, that is minus 18, minus 6 plus 4 will give me minus 20x. And then 81 minus 36 plus 5 will give me plus 50. So you had to boil down the baji, in other words. When you boil down the baji and you divide the baji by 2, you'll end up get a nice little quadratic. And of course, you have to factorize the quadratic. And in this case, we just get in one answer, x is equal to 5. And so that one answer, x is equal to 5, we will sub in equation 1 to get y is equal to 4. Hence, a is the 0.54. So I think simultaneous equations with circles is pretty easy. What you all think about this? So you can see here, I have the line 2x minus y plus 4 is equal to 0. And it intersects this circle, x squared plus y squared minus 6x minus 2y minus 7 is equal to 0 at 2 points, the point P and Q. Find P and Q. Of course, I'm gonna put my two equations here, equation 1, equation 2. And I'm gonna substitute for y from equation 1, y is equal to 2x plus 4. So I'm going to sub that in equation 2. So x squared plus y squared will be x squared plus 2x plus 4 squared. Minus 6x plus minus 2y, which is 2x plus 4, minus 7. And of course, I am just expanding all of the brackets here. So this 2x plus 4 will expand out to be 4x squared plus 6x plus 16. Plus 16x plus 16, sorry. 4x squared plus 16x plus 16. I have the minus 6x, and then this minus 2 will expand out with these brackets to give me negative 4x minus 8, and then I have my minus 7 here. Of course, when I boil down the baji, I will just get 5x squared plus 6x plus 1 is equal to 0. And of course, I do have to, when a is not, remember when a is not 1, you have to multiply these two numbers there. And you want to ask yourself, well, what two numbers that when I add them, that when I multiply them, I will get 5. 5 times 1 is 5. But when I add them, I will get 6. And of course, the only answer there is 5 and 1. So I substitute in the middle value with 5x plus x, and I factorize from there. And I'll factorize to get me, factorize by grouping to get me 5x plus 1 into x plus 1 being my factors. And so from these factors, you could see here that I get two answers for x. I get x is negative 1 over 5 and x is negative 1. So now I will sub both of them inside of equation 1. So sub x is negative 1 over 5 in equation 1, and I used y is equal to 2x plus 4. I used that version of equation 1 to get y is equal to 3 and 3/5. So I have negative 1 over 5 into 3 and 3/5. Right? And then we have this one here, which is x is equal to negative 1 in equation 1. So 2 times negative 1 plus 4, that gives us all of this here. So I have the first point being P and Q. I guess you could have named it PQ the other way as well, and it wouldn't really matter. So you can see when you do the quadratic and you end up with two different answers, that means it's a secant, right? So these here are two examples that you should do for homework, so you can just screenshot that. That's it for today. If anybody have any questions, I will see you Wednesday. Have a good weekend.